Here is an example showing how to use R to find probabilities for normally distributed data sets. So again, we need a data set to work with. Here's an example. Porphyrin is a pigment in blood protoplasm and other body fluids that is significant in body energy and storage. Suppose that the number of micrograms of porphyrin per deciliter of blood has a mean of 38 and a standard deviation of 12 and is approximately normally distributed. So the first thing we do on every problem is we state the random variable. This is what we measured. So they measured the number of milligrams of porphyrin per deciliter of blood. So that would be my random variable. We usually use x for a variable, so I call it x. Then state the mean and the standard deviation. So the mean is 38, it says in the problem, and the standard deviation is 12. And then it asks us to find the probability that the number of milligrams of porphyrin per deciliter is less than 60. So we're going to translate that into symbols. The probability that the number of, so the number of was x, so we have the probability that x is less than 60. So this is less than, just transfers right into right there. Alright, we do know it's a normal distribution because we were told it was approximately normally distributed in the problem. You have to be told that on these problems, so we know that. So we know we're doing a normal distribution. So we're looking for the probability that x is less than 60. In R, anytime you want to find the probability that something is less than, you use a p, and then you start off with whatever your distribution is. In this case, the distribution is normal, so it's p norm. Then you type in where the shading ends, and then you type in your mean, which our mean was 38, and then you type in your standard deviation, which was 12. So 38, 12. So our shading stopped at 30, I believe it was. Oh no, I'm sorry, 60. So we'll change that to 60, and then we'll see what we get for a value. And we come up with 0.9666. So that is the probability that x is less than 60. Now let's find the probability that the number of milligrams of porphyrin per deciliter is greater than 16. So again, translate that into symbols. We are looking for the probability that the number of, which was x, is greater than 16. So here's our shading, but in R, everything is, p is for less than. So we actually want to know this area here. If we use the p, we'd find this area. Since the total area under the normal curve is 1, then if we find this area, we just have to subtract from 1 to get the big shaded we wanted. So we'll actually put that into R that way. We'll say we want to do 1 minus p, because we're doing the probability of less than normal, 16, and then was the value of where the shading, in this case, started, but we're thinking of where it ends with the 1 minus, and then 38 and 12. So you find out what that probability is. It happens to be the same thing just because of symmetry. It works out nicely that way. And then let's do one more of these. Let's find the probability that x is between 18 and 72. So in order to do that, we have to think about where we're less than. Less than 18 would be this area here. So if I found the p norm of this area, I know that. Less than 72 would be all of this. So from this 72, all of this all the way down. So if I take all of this and then subtract off that little tiny piece, I'd get the area in between. So you have to do a little bit of work on this one. And so we do p norm. And we're going to start with the bigger one because we want to do the bigger minus the smaller. So the bigger less than is at 72. And we're going to find this probability all the way down. So it would be p norm 72 with the mean of 38 and the standard deviation of 12. You can find out what that number is, but we don't really care. We want to subtract off the smaller part. So we do p norm. And then we look at where that smaller part shading is, and that was 18 on down. So this is the area we're looking for here. So that would be 18. So we again go back to here when we put in 18, 38, and 12. And there's your probability of being between 18 and 72. There is one more problem. It asks us to find the probability that x is greater than 69. So again, shading greater than 69 would be this area up here, but the p-norm always finds the area to the left. So we want to figure out this area to the left and then subtract from 1. So in R, you can do that all in one step. We're going to do 1 minus p-norm. And then again, the value where the shading is going to basically end is 69. So we type in 69, 38, and 12. Notice you get a really small number, 0.00489. That makes it something unusual. So usually if you get a really small probability, the chances that it happening are very unusual. So if it does happen, you might think about something about this patient. And that's it.